And let's go over and take a look at what we're doing tonight. So let me flip over to the camera. All right, so tonight we are starting a new unit. So just a couple of reminders first, though. You have homework due tonight on 5.1 and 5.2, and then you have the Unit 3 test. Okay, and remember that covers Chapter 4 and Chapter 5. So 4.1 to 4.3, 5.1 and 5.2. So you need 60% on each of those homeworks in order to unlock that Unit 3 test. Okay, so the 5.1 and 5.2 homework due tonight along with the test. All right, and I gave you a chance on questions. I'll ask again at the end of class if anybody has any questions. So tonight, we're going to go over 6.1 and 6.2. We start a new unit, and we're going to be talking about the normal distribution. So I like this little graphic. It says, I'm not just normal, the most normal kind of normal. So we're going to talk about actually this week the standard normal, and then we're going to talk about some special kinds of normal distributions. So we're talking about this week continuous random variables. Remember last week we learned about discrete random variables. So now we're moving on to continuous random variables, and we're going to talk about two of them. And the most important one, which is probably the most important distribution that we talk about in statistics, is the normal distribution. Okay, and we can have all kinds of normal distributions. So first we're going to learn in this section about the standard normal distribution. And it has three properties. So the normal distribution is simply the bell-shaped curve. Most students know about that. It's bell-shaped. Here's a nice picture of it. And a lot of the data that we study has a bell-shaped or a normal distribution. That's pretty much how we describe a lot of nature. It's got a normal distribution. Okay, in a standard normal distribution, the mean is equal to 0. So this picture here is actually any normal distribution that's centered at the mean mu. We're specifically talking about the standard normal distribution, which has a mean of 0 and a standard deviation of 1. And that was like that picture that I just had on my little agenda sheet. There's a standard normal distribution, centered at 0, and the standard deviation is 1. And if you notice along the y-axis, or x-axis rather, it goes 1, 2, 3, negative 1, 2, 3, and they actually are going to correspond to z-scores that we learned about earlier in the course. Okay, so there actually are many kinds of normal distributions, and we're going to cover that in a second in 6.2, because you can have any mean and any standard deviation. Doesn't matter, it depends on the actual application that you have, but we're first going to learn about the standard normal distribution. And just to give you an idea of the mathematics behind the normal distribution, this is actually how we find the probabilities. It's an awful, awful, awful formula. If you notice that the mean and the standard deviation for the distribution, for the parameters, are actually up here in an exponent. And it's got base E in it, and it's really awful. You can't, this is not able to be calculated in what we call a closed form. It has to be done by approximation. So we're going to use a calculator in StatCrunch to do our calculations, or you could use a table. The other continuous random variable that we're going to learn about today is the uniform distribution. This one's different from the standard normal because this one has all the probabilities. It's all going to be in a rectangle, because everything's going to be equally likely. So the area under the graph of the continuous probability distribution, all the areas are always equal to 1. Let me go back up here for a second. The area under the curve of any normal distribution, that area is going to be equal to 1 because that's going to become the probability. Okay, so the same thing's going to happen with a uniform distribution. The difference here is it's not bell-shaped. It's going to be rectangular because all the outcomes are equally likely. So we're actually going to figure out the probabilities by the area under the figure. So the height times the width, and I'll show you how to work those problems. So its continuous random variable has a uniform distribution if the values are spread evenly over the range of possibilities, and it results in a rectangular shape. So different from the bell-shaped curve that we see for the normal. So the graph of any continuous probability distribution has a special name now. It's called a density curve. And the area under the curve, whatever it happens to be, whether it's a normal distribution or that rectangle, is going to be equal to 1. And that's because, as I just mentioned, there's a correlation or association between the area and the probability, because that's how we're going to work our problems. To find the probability, we're going to find the area under the curve or the area under the rectangle for the uniform distribution. So let's just take a look. There's a nice standard normal for you. So the area under the curve is 1. It's centered at 0. It has a standard deviation of 1. So if we go 1 standard deviation here, 2, 3, 1 below here, 1, 2, 3. It's called a standard normal distribution. Again, mean is 0, standard deviation is 1. A little bit of nomenclature, which you've seen before. In a normal distribution, because it's a continuous variable, it doesn't matter whether you say less than or equal to, because in a continuous distribution, the variable can never take on a single value because area is not measured on a point. It's measured between two values. So you're going to see the probability that a particular z-score, in other words, these are z-scores now, between two numbers is written like this. If we want to look at it greater than some number, we're going to write it like that, less than. And you're going to use these when you use your tool in StatCrunch. And again, there's a table in your book, but we're going to use a calculator in StatCrunch. Be careful when you're using a normal distribution. Z-scores and area are different. Okay, z-scores, or the values in the distribution, are going to be along the x-axis. The probabilities are going to be the area under the curve. Okay, so you want to be careful that you understand exactly what it is that you're learning about or that you're working with. Are you working with a z-score? Are you working with a probability or an area? And then this was a question actually in your reading quiz. It was about the critical values, and they're not the crucial values, they're the critical values. So critical values, so some people, when we get into hypothesis testing in another 2 weeks, I guess, 3 weeks, when we do hypothesis testing, one of the ways we might do it is we might look at what we call critical values. So for instance, does the value of the test statistic go beyond a certain value along the normal distribution? And those are called the critical values. So for instance, for 95% of the data, if you remember in the empirical rule, we said was within 2 standard deviations of the mean. It's actually a little bit less than that. It's 1.96 standard deviations above and below. So this would be called a critical value. So in other words, 0.025 is in each of the tails there, 95% is in the middle. And again, this will become more important in subsequent sessions. We don't focus too much on it, but you may see it mentioned in a problem periodically. So I wanted to introduce that. Okay, so let's do a couple of problems. First, we're going to do uniform distribution, and then we'll do the normal distribution. Now, there is a calculator for the normal distribution in StatCrunch, but I don't want you to use it because these are problems that I can ask you to work by hand on the final. So they're not hard either. And I'm going to show you how to do them. They're really, really easy to do. Okay, so let's assume that the weight loss for the first month of a diet program varies between 6 and 12 pounds. Okay, so the first thing I would do is make sure my pencil has lead in it, is draw a picture with a rectangle of what I'm talking about. So I go between 6 and 12 pounds. And it says that it's spread evenly over the range of possibilities, so there is a uniform distribution. Okay, so right away I know it's uniform, so I can go ahead and I can draw a rectangle here. So this is going to represent my probability here. We want to find some probabilities here. Now I want to talk about this first. How do we figure out what the area is? So it's a rectangle. So what's the area of a rectangle? Everybody should remember it's the base times the height, right? Or I shouldn't say that. It should be length times width. Let's make it length times width. That makes more sense. We'll do length times width. All right. So the width here is going to be the height. Okay, so what's the length of this along the x-axis? How many pounds do we have to go to get from here to here? How many pounds is that?
6.
6, right? Okay. Now, I know the area has to equal 1, don't I? I just told you that. The area in that rectangle has to equal 1. So I know that the length is 6. So what I need to know is, what does the width have to be in order for this area to be equal to 1? So I have an equation here. I have 1 equals 6w. How do I find w? Divide both sides by, how am I going to solve for w?
Divide both sides by 6.
Excellent. Very good. So the height here is 1 over 6. So the length along the x-axis, I'm going to put it up top here so you don't get confused. This length here is 6, and the height is 1/6. So if I multiply 6 times 1/6, I get an area of 1, which is what I have to have. It has to be equal to 1 for it to be equal to similar, to be able to do probabilities. Now we want to do, let me get a colored pen here. We want to find the probability that we lost on this diet more than 10 pounds. So I want to find this area right here. So it's a little tiny rectangle now. So how do I find the area of the probability? So area equals probability equals length times width. Okay, so how far is it from here to here? How many pounds? How far from 10 to 12?
2.
2. And I know the width is 1/6 because I just calculated that, right? The width of the height. So this is equal to 1/3. So there's a 1/3 probability that I'll lose between 10 and 12 pounds. If this is true, if it's uniformly distributed, the weight loss between 6 and 12 pounds. That's all you do to work the uniform distribution problems. We're going to do another one. Let's do one here. So now we want to do between 8 and 11 pounds. So I'm just going to go ahead and draw my picture down here again. I'm still going from 6 to 12 because that's my original distribution. And this is 1/6. And I said the distance up here overall is 6. Now I want to go from 8 to 11. So I'm going to go ahead and shade in that center region. So again, the area, whoops, just broke my lead. Area is equal to the probability. Okay, so how far is it from 8 pounds to 11 pounds? How far do I go to get from 8 pounds to 11 pounds?
3.
3. So it's 3 times, and again, my height is 1/6, so this is 1/2. So the probability that I lose between 8 and 11 pounds is 1/2. That's 1/2 of the area inside of this whole probability distribution is 1/2, or density curve, actually, is more correct terminology. Okay, let's do another one. Okay, so this time your friend is often late to meet you for lunch. Assume the times she's late are between 0 and 30 minutes and are evenly spread over the range of possibilities, so there's a uniform distribution. All right, so let's draw our picture. So 0 to 30. Whoops. All right, so I know the distance here is 30 minutes, right? What's the height going to be here? What's the height of this rectangle going to be? Remember what we did up here? The length here was 6, so the height was 1/6. So what's the height here going to be? 1/30.
30.
Yep. Yep, they're always going to set up like that. Now we want to do, let's get a different color. Oh, I just don't have a green one out. Oh, here's a purple one. All right, we want to find out what's the probability your friend is going to be between 20 and 25 minutes late. Okay, so just like we did before, area is equal to the probability, which is equal to length times width. Okay, so how many minutes is it from 20 to 25?
5.
Yep, 5 minutes. And the height here we said is 1/30. So this becomes 5/30 or 1/6. And you're done. So these are very easy to do by hand. There is a uniform calculator in there, but I will tell you, I'm going to ask you one of these on the final exam because it's one of the few questions you can do by hand. That's not difficult. Okay. All right. Now let's go do some where we're going to use a calculator, because when we do the normal distribution, we're definitely going to use a calculator. Okay, so what's going to happen on these is they're going to present these in a couple different ways. So the first way is going to be, they're going to show you a z-score on the standard normal, and they're going to have a shaded area, and they're going to ask you to find the region, the area of the shaded region, which corresponds again to a probability. We have a standard normal with a mean of 0 and a standard deviation of 1. Okay, so what you're going to do is, I'm going to switch over to my, actually what I'm going to do is use the handout electronically so I don't have to keep switching. Because, okay, I need to get to StatCrunch. So let's go over here. And I guess I don't have my StatCrunch tool anymore. Okay, so let's open up StatCrunch. And I'm just going to open up a blank sheet. All right, so I'll see if I can get these side by side in just a second so you can see it. Okay, so let me find, just bear with me for a minute because I have that handout over here. And this is the problem right here. All right, oops, went too far. Okay, so there's the two we just did. Okay, so here's the one we're going to do now. So I'm trying to put these side by side so you can see them. All right, so the problem says, it's the right one? Yep. Okay, so it says find the area of the shaded region. Okay, so it's a standard normal. So what I'm going to do is I'm going to go to, you've used calculators before, stat calculator, and you're going to go to, whoops, the normal calculator, which is right here. Okay, Now, it'll automatically be set up as standard normal. So for this section, you don't have to change the mean and standard deviation. It'll be set up for you exactly like you need. Now, you want to find the probability, and down here, you're going to put in the z-score that's given to you on the picture. And I'll show you what happens. It's very nice because it'll show you a graph just like you see here. See how nicely it's shaded, just like the picture that you have there. Here's your answer right here. So the probability that a z-score is 0.44 or less is 0.6700. 0.6700. Okay, let's do the next one. What's different about this one? This time they want the area to the right. So you're going to change your inequality here. And notice here, you don't have an equal. You only have two choices, less than or equal to or greater than or equal to. In a minute, I'm going to show you the betweens, but right now we're going to go either left or right. Okay, let's do the second one. Now we want to do greater than or equal to, and we have a negative 1.04. Put that in there, and there's my probability. And again, the picture looks very similar to the one they've given me, so I know that I'm oriented correctly. And the probability here is 0.8508. So the probability that the z-score would be negative 1.04 or greater is 0.8508. Okay. Now we have a between one. So does everybody follow what we did on the first two? So you're going to go to Stat, Calculator, Normal. It's going to be set up for standard normal automatically with a mean of 0 and a standard deviation of 1. You're going to work down here. If you want to find the area to the left, you're going to leave this as less than or equal to, and you're going to put in the z-score you're interested in right here. So we did 0.44, and we got 0.6700. If you want the area to the right, you're going to change this to greater than or equal to, and put in the z-score that you're interested in, and we did negative 1.04. For the next one, it was 0.8508. I'm pretty sure all the answers are going to be asked to give 4 decimal places. That's pretty common for area under the curve and probability for the normal distribution. All right, now we're going to do a between. So look at the next problem. And you have a little between option right up here on your calculator. So click that. And you're going to put in the one number here. So this is negative 0.84. And this one is 1.28. And then you're just going to click compute. And again, it's going to shade the area just like the picture you were given. So you make sure you're kind of in the right area. And so I got 0.6993. Okay, so that's a between. So we did to the right, to the left, to the right, and then we did a between option. And we all use the same tool here. Once you open the tool once, you just might as well keep it open because you're going to use it over and over again through all the problems in this section. Okay, now let's flip it around. Let's go back to the standard. Now, instead of giving me the value along the x-axis, the z-score, they're going to give me this time the area, and they want to know what the z-score is that corresponds to that area to the left or to the right. Okay, so what you're going to do now is, let's make sure we go to the left here so we have a less than. Now you're going to put that probability over here. So we have 0.8907, compute. And so the z-score that has an area or a probability of 0.8907 to the left is 2 decimal places, 1.23. So that z-score right here, 1.23, has an area or probability to the left of 0.8907. Okay, let's flip it around to the other side. We want to do a greater than this time. And now you're going to put in the area that was given to you, which is 0.9265, compute. And we get a negative z-score. Again, the picture looks like what I was given, so it's negative 1.45. So a z-score of negative 1.45 has an area or probability of 0.9265 to the right, or greater than that value. All right, questions on the tools so far? Are we okay? We're going to do a couple more now too. Okay, so in your homework, they're going to look just like this. They're going to give you a picture, and then they're going to say either find the z-score or find the probability. So they'll be just like these. I think their colors are different, but the problems are the same. Okay, this next one, let me just minimize this. I'm going to stay out here because there's no reason to go back to the camera right now. Uh-oh, somebody's got their audio on. Assume a randomly selected subject is given a bone density test. These test scores are normally distributed with a mean of 0 and a standard deviation of 1. Find the probability that a given score is less than negative 1.06 and draw a sketch. So the first part of the question is multiple choice. And they want you to pick the picture that corresponds to find the probability that the score is less than negative 1.06. So which of those graphs would be the correct graph to show a score or the probability that the score is less than negative 1.06? Anybody want to try?
A.
Yeah, it's A, right? It's right here. Because that's the area less than. So it's going to be A. So that's a multiple choice part. And then the second part is find that probability. So let me find my tool. It's here somewhere. There we go. All right. So we're going to go back to the standard. And we want, oh, hold on a second. I got all my Zoom tools in the way. Okay, we're going to go area to the left. So I went less than or equal to, and I'm going to put in negative 1.06. And my probability is 0.1446, 4 decimal places. Okay. And by the way, bone density, I don't know how many of you are aware of it, they do report out as a Z-score. This is 1 standard deviation below the normals for your age. This is 2. I think osteopenia is at -1 and osteoporosis is at -2. So if you're 2 standard deviations below your gender and age group, that's how they classify your bone density. All right. Now I have another one here, which says, minimize this. Find the percentage under the curve of the standard normal and then convert it to a percent and fill in the blank. So it says approximately what percent of the area is between -2 and +2. Actually, I'm going to come to the camera just for a minute because I want to try to motivate this question before we use the tool. All right, so let me flip over to this page. Whoops. Here we go. It's down here. Okay, I want you to think about this for a second. All right, so let's draw a standard normal curve here. It's got 0 in the middle. And it wants to know what approximately blank percent of the area is between Z equal to -2 and Z equal to +2. All right, so what I'm going to do is think about what's happening here. So it's within 2 standard deviations of the mean. Actually, I don't need this. Actually, we can do this on the tool. Let me go back to the tool. Come on. Oh, it's not going to work. There we go. No, I can do it right on the tool. I thought I needed the paper, but I don't. Let's go back to the tool. All right, where's my tool? Okay. All right, so what we're going to do here is, let's go to the between. And we're just going to put in here -2 and +2 because we want to go between 2 standard deviations below and above. And remember when we did the empirical rule, what did we say? Approximately what percent of the data is within 2 standard deviations of the mean? Who remembers? Remember your empirical rule from way back in chapter 3? Anybody remember? Remember the 68, 95, 99.7% rule? It was approximately 95%. The actual percent is about 95.45%. So it's a little tiny bit more is within 2 standard deviations. So this is telling you the exact percent. The empirical rule was a nice approximation. Okay, let's actually, while we're here, I think you might have this for homework. Let's go between 3 and -3 and +3. In the empirical rule, we said that was 99.7%. 99.7%, pretty good. And then let's go -1. So within 1 standard deviation. Remember the empirical rule said 68%. Let's see what we get. 68.3%. So a little tiny bit higher. So that kind of shows you how the empirical rule relates to the actual, finding the actual area or probability under the standard normal curve. All right, let's see. So I think that's the end of the problems for 6.1. That's the end of the problems there. All right, so let's go to 6.2. Because 6.2 is going to be real similar to what we just did in 6.1 with just a little tiny bit of a change. So what we're going to do in 6.2 is, instead of a standard normal, we're going to have normal distributions with any mean and any standard deviation. Okay, and your author of your textbook is going to talk about you doing a translation of converting from the non-standard. We call a normal distribution that doesn't have a mean of 0 and a standard deviation of 1 a non-standard. If you weren't using a technology like StatCrunch, you would actually have to create the z-scores and then look up the probabilities. But because we use StatCrunch, we don't need to do that. But you remember your formula for z-score, though. It's helpful to remember it. We take the data value we're interested in, subtract the mean, and divide by the standard deviation. And I mentioned before, z-scores are always going to be 2 decimal places. But the normal tool is going to do the standardization for you. Sometimes they're going to ask you in a question what the z-score is, though, so you still want to remember how to do that. Okay, so again, we're going to use these. I'm going to show you with the tool. The difference is going to be this time, you're going to enter the mean and standard deviation given in the problem. The bottom part of the tool will work the same way that we just went over. Again, don't confuse your z-scores and your areas. Z-scores are distances along the horizontal axis, but areas are the regions under the curve. They're the probabilities. A z-score is negative if it's on the left side of the normal distribution. That's when the z-score is less than the mean, and a z-score will be positive when it's on the right side. So we're dealing with an x-score greater than the mean. And we're going to use the same criteria for significantly high and significantly low. So the probability of x or greater, if it's less than or equal to 0.5, it's significantly high, just like we just did with the binomials. And significantly low if the probability of x or less is less than or equal to 0.05. You might want to go back and look at your quartiles and percentiles also from section 6.3.3, because we're going to talk about those in here also. So you might want to review that a little bit because you might not remember what they mean. Okay, so let's do some problems. And I think I'm just going to, I'm going to go over and use everything on the computer. So just bear with me for a second. Let's flip over. Because I can just pull up the handout and we'll work it that way. Okay. All right, so let me get your handout for 6.2. Okay, so let's get to the problems. Here we go. All right, so the problem looks very similar to what we just did before, but now the difference is we don't have a mean of 0 and a standard deviation of 1. We have some other kind of mean. So this time we're working with IQ scores. And the IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. So the first thing you want to do when you open up your tool is go ahead and put in that mean. You're going to use the standard here. You're going to put in that mean and that standard deviation. So you don't want to do that first so you don't forget. All right, now we can answer the question. Let's see what they're asking us to do. What did I do here? Went out of my StatCrunch tool. There we go. So we want to find the probability if we selected one adult that their IQ score was 118 or less. Okay, so area to the left. So we want to make sure we have less than or equal to here, and we're going to put in 118 and we're going to compute. And again, you might want to take a look and make sure that the picture you get here looks very similar to the one given to you in the problem. If there's a picture given, there's not always a picture given. And so the probability that a randomly selected adult would have an IQ score less than 118 is about 0.8849. And then let's go greater than 91. So we're going to go change this to greater than or equal to, and we're going to put in the 91 IQ score and compute. And so now we've got the probability a randomly selected adult has an IQ score above 91 is 0.7257. And then just like we did in the other section, we can do a between. So click on your between here. And we're going to go from, they're asking us to go from 79 to 133. And we get 0.9053. And again, that picture looks very similar. I want to point out for you also, once you go and put in a mean and standard deviation other than 0 and 1, you have this option here called the 68, 95, 99.7 tick marks, which is the 1 standard deviation, 2, 3. If you click on that, it's actually going to label the x-axis with -1 standard deviation, -2, -3, +1, +2, +3. That's kind of helpful because this StatCrunch tool doesn't give you the z-score, but that's what give you an idea of where the z-score might be. So for instance, here a z-score of 85, I'm sorry, a z-score of 79 is between, for a z-score 4 and IQ score of 79 is between -1 and -2 z-score. An IQ score of 133 is between a z-score of 2, because this is 2 standard deviations above, and a z-score and a standard z-score of 3, because 145 is 3 standard deviations above. So that's kind of a nice option there, because you don't get the z-score. Okay, so if you want the z-score, you would have to do that by hand. So for instance, let's do one. Let's take the 133 and calculate the z-score. So to calculate the z-score, you take the data value, subtract the mean, in this case is 100, and divide by the standard deviation. And so that has a z-score of 2.2. So an IQ score of 133, it's pretty significant. It's 2.2 standard deviations above the mean of 100. Okay. All right, let's see what else I asked you to do in here. Okay, so now the same thing we did before, I'm asking you to find the z-scores that correspond to certain areas or probability. So I want to know what IQ score is the IQ score that 99.2% of people are lower than. Hold on just a second. I'm going to turn this off for a minute. Sorry, I forgot to turn my home phone off. They're all spam calls too. So, okay, so now you're going to go back to the standard, and you're going to go again, just like you did before. You're going to put the area over here, the probability 0.9918. Oh, I want to go less than, because I want to go on that side. So I want to put in 0.9918, compute. Okay, so an IQ score of about 136, 99.18% of people would be expected to have an IQ score below 136 rather. Okay, and then let's find the one that about 15.87% of people would exceed. So I'm going to go greater than, and I'm going to put in here 0.1587, and that IQ score is about 115. And then, oh, I have another one on the left side. Okay, what IQ score would we expect about 97.98% of people to exceed? So I'm going to change this here to 9798. And that would be about 69.2. That's really low IQ score down there. And notice here, that's like 3 standard deviations below the mean. No, 2, I'm sorry, 2 standard deviations. Yeah, we could calculate that. Let's get our calculator. Let's take 69. Let's just calculate that. 69 minus 100 and divide by 15. So that's going to be -2. So a little bit more than 2 standard deviations below the mean. That's pretty low. All right. Okay. So let's do this one here. Now we've got pregnancies. Lengths of human pregnancies are normally distributed with a mean of 268. So the first thing I'm going to do is put my mean in, so I don't forget. And the standard deviation is 15 days, so it's the same. What's the probability a pregnancy will last, I should say will last, at least 300 days? Okay, now you don't have a picture this time. What am I going to do down here? How do I do that probability? The pregnancy lasts at least 300 days. So am I doing a greater than, or am I doing a less than? You might want to try. So it's at least, go ahead. Greater than, yeah, it's going to be greater than. At least 300 means 300 or more. So we want to go greater than 300 days. That's a long pregnancy. Oh, I said the wrong one. I'm sorry. After I said that, I put the wrong one in. There we go. Yeah, it's pretty unusual. 0.0164. So only about 1.6% of pregnancies would last at least 300 days. That's really, really long. That's 10 months. Now, look at the next part of the question. Using the criteria that X is significantly high if the probability of X or greater, which is what we just calculated, is less than or equal to 0.05. Is this less than or equal to 0.05, this probability? Is 0.0164 less than 0.05?
Less.
Yes, yes. So is this pregnancy significantly long? Is a pregnancy of 300 days significantly long? Yes, very much so. Okay, so everybody understand that's the same rationale we used last week with the binomials. 300 or more, if that probability is less than 0.05, it's significant. Okay, let's do another one. We got a couple more here for you. So it says in one region, the September energy consumption levels for a single family home are found to be normally distributed with a mean of 1,050. So I'm going to put that in 1,050 kilowatt hours and a standard deviation of 218 kilowatt hours. For a randomly selected home, find the probability the energy consumption in September is between 1,100 and 1,225. So I'm going to use my between option. And I'm going to put in the lower bound, which was 1,100 and 1,225. And I get my probability. Okay, so for that particular house that was randomly selected, the probability that they'd consume between 1,100 and 1,225 kilowatt hours is 0.1982. All right, any questions? I'm not hearing any questions. Are we okay? Overwhelmed? Anybody? Gonna get a little harder in a minute.
We don't like
All right.
harder.
That's what's that?
We don't like harder.
You don't like harder. I want you to think. Come on, come on. I shouldn't say harder. They're more thinking questions. All right. Remember I said to review stuff about your percentiles and your quartiles. So let's take a look at this one. Bank's loan officer rates applicants for credit. The ratings are normally distributed with a mean of 200. Okay, so I'm going to put my 200 in, 200, and a standard deviation of 50. They want us to find P60, the score that separates the lower 60% from the top 40%. How am I going to do that in my tool? I'm going to go back to the standard tool. Where am I going to work that problem?
Should it be between, since it has two different percentage?
Well, no, we only want to find one number. We want to find the 60th percentile, which is the score that separates the lower 60% from the top 40%. So it's only one number I want to get, not two, just one.
Okay.
But how am I going to get that? So first of all, I want a number on the rating scale. I don't want to find a probability because I already have something about the probability here. Because I have the area rather, the 60 from the 40.
So
So
do
I'm going
you
to be,
change out the percentage to
yes,
decimal?
yes. And I'm going to put in here the 0.6. And oh, I got to change this to less than. Okay, so there it is. So a credit score of 212 they're probably only going to do one decimal here, 0.7 would separate the bottom 60% of the customers or the applicants from the top 40%. Which makes sense because the mean is 200. So it's a little bit more than the mean. And so it's 10% higher than the, it's getting up to the 60%. So it's a little bit higher than the mean and it's actually at 212.7. So that's a percentile problem. So that's how you're going to do a percentile. So if they ask you to find the 83rd percentile, I would put in 0.83 and compute. And so a rating and the credit rating of 247.7 would separate the bottom 83% of the applicants from the top 17%. So 83% of people would have that rating or lower. That's what percentile means. Now, how about a quartile? Let's do the next one. The amount of rainfall in January in a certain city is normally distributed with a mean of 4.5 inches. I'm going to put that in, 4.5, and a standard deviation of 0.3. Find the value of the first quartile. Quartile 1. How am I going to do that? Remember what the
0.25? 0.25?
Yes, very good. Yes, yes. And it's going to go in your area window here, 0.25. Very good. So about 4.2, 4.3. So a rainfall of 4.3 inches would be at the first quartile. Okay.
My question though,
Yes.
Since you used a less than sign, how do we get to understand when you use a less than versus a greater than?
Depending on whether you're going to the left or to the right. So if you're trying to find a probability of something less than, you're going to go less than its area to the left.
Yeah, I understand it with the with the diagram, with the drawing.
Okay.
But like if I don't have a drawing, then
well, let's go back to the pregnancy problem. So it said at least 300 days. So are you going to be calculating area to the left or to the right? You want 300 or
you
more.
want more. So
that's going to be on the right.
Okay.
Yeah, so sometimes it helps. Some students like to make a picture
Yeah.
and draw it on a
picture
piece
is
of
helping
paper.
better.
Yeah, sometimes that helps to actually draw it on a piece of paper and say to myself, what is it actually that I'm trying to find? And actually, we might want to do this with the next one. Okay, let's take a look at this next one. So it says, let me move this out of the way. Assume that men's heights are normally distributed with a mean of 68.6 inches. So I'm going to put that in, 68.6 inches, and a standard deviation of 2.8 inches. All right, so now we've got a plane here, an executive jet that seats 6 people and has a doorway height of 51.6 inches. Okay, so here's a good example for you. What percent of the men can fit through the door without bending? And the door height is 51.6. So let me go over to the let me jump over to the paper. Let's look at this on a piece of paper before we answer it on the tool. All right, so let's take a look at this. I gotta pull it up here. Okay, so let's take a look at, oh, what did I do there? Something popped up I didn't want. Okay. All right, so let's take a look at this and think about what this is saying. All right, so we have, here's my curve, and the mean is 68.6 inches. And the door height is 51.6. So it's down here somewhere on the curve, 51.6. Okay, we want to know what percent of men can fit through the door without bending. So on my curve, where do I want to find the area of the probability? Do I want to find it? How tall does the man have to be so he doesn't have to bend to get through that door? Does he have to be shorter than 51.6 or taller?
Shorter.
Shorter. So you're going to be finding this area over here. Okay, so let's go back over to our tool because I already set it up for you. So go find our tool. So we're going to do this as less than, and we want to make it fit, what was the height? 51.6. So before I hit compute, do you think very many men are going to be able to go through that door without bending? If the average height is 68.6 inches, what do you think?
They have to bend.
Yeah, most of them are going to have to bend, right? Because look at this. Now, let me explain this probability to you. This is in scientific notation. Look at the curve. There's nothing colored here, is there? So basically, this probability is 0. I mean, 51.6 inches is about like 4 feet and 3 inches. I mean, not very many men are that short. So this probability, if you notice on the curve, there's nothing colored here. There's no red color on here. This is basically 0. Okay. So no men are going to be able to fit through that doorway without bending. So is this a good design? No, it's not. Why didn't they make a bigger door? So why didn't the engineers make the door higher for the plane? Anybody know? What do you think? Why are they making even women are going to have to stoop? How come everybody has to bend to get onto that plane? Anybody know? What do you think? Anybody? Anybody ever been on one of those little tiny jets? They're really, really tiny. There's no more room. That's why. I mean, they just can't. I mean, it's just there's limitations on the size of the jet. But let's talk about what doorway height would allow 40% of the men to fit without bending. Okay. So now what am I going to do? So my 40% is going to go over here, right? This is like the percentile. And am I going to do less than or am I going to do greater than? So again, if they're not going to bend, do they have to be on the left side or on the right side? Shorter than or higher than? Shorter, right? Because we just did that on the other one. So if we made the doorway 67.9 inches tall, 40% of men would be able to get on without bending. And you can see it on the picture here. Let's do the tick mark so you can see it better. So there's the number we just calculated, 67.9, which is a little bit below the mean. So if you had that doorway height, 40% of the men would not have to bend. But again, the problem with it is the design of the plane has limitations on how high the doorway height can be. I think that's it. Yeah, that's it on the problems that I gave you this week. All right, so let me jump over to, we can stay right here actually. Let me keep this open. Let me go find, all right, let me turn this down, shut that down. Let me find your homework. Let's take a look at your assignment so you can see what they're going to look like. Here we go. So let's go to chapter 6. So we did 6.1 and 6.2 today. So 6.1, let's take a look. So there's a number of definition questions in the beginning like there usually is. So I'm going to skip over those. That's a definition question. Okay, so this is a uniform distribution question. Let's see if we can do it without a picture. If not, we'll draw a picture. Okay, so it says the waiting times between subway departure schedule and the arrival of the passenger are uniformly distributed between 0 and 7 minutes. Okay, so when I draw that rectangle, how high is that rectangle? It's going to be 7 inches or 7 minutes long. How high is the box going to be? Remember when we did the uniform distribution problems? What happened when we did the height of the box? It became 1/7.
7.
Right. Now find the probability that a randomly selected passenger has a waiting time greater than 4.25 minutes. Okay, so if I had a pencil and I could draw on here, but I can't, unfortunately, you can't draw on the MyMathLab stuff. You want to find the distance from 4.25, it says greater than, from that to 7 minutes. So let me get my calculator. Oops. Get the computer calculator here. Here it is. So how far is it from 7 minutes down to the 4.25?
2.95.
Nope, I did it wrong. What to get? Hold on a second. Clear. 7 minus 4.25. 2.75, right? And then you're multiplying by 1/7, which is the same thing as dividing by 7. So the probability would be 0.392. How many decimals? 3 decimals. 0.393. 3 decimals. 0.393. Okay, so you could use a picture, or if you can think it through in your head, you can kind of do it like that, like we just reasoned through it. So you have a couple like that. That's the departure times. Here's one with a graph. They already show you the graph here. What's the and actually shows you the height. Look at that. They gave you that part of it. And then there's one here about statistics professor with the lengths of her classes are uniformly distributed between 50 and 55 minutes. So that distance there is 5. So the height of the rectangle will be 1/5. And then you want to find the probability the class runs between 51.25 and 51.75. So find that distance and divide by 5. So here's the ones we went over in 6.1, just like I showed you with pictures. I said the colors are different, but you want to find the area here to the left of 0.74 for the z-score. They give you links to the tables. You don't want to do that. You want to use StatCrunch. Definitely. You don't want to use the tables. It'll take you forever. Then you have an area to the right, just like I did. And then you have an area between. And then this is the one I went over with you, but the bone density, we did one like this, pick the right graph, and then you'll do the probability. And then the same thing on this one. Got a couple like that. And another one like that. And then I actually did these for you. What percent of the data is between z equal -1 and +1? Remember, you can use your StatCrunch tool between option -1 to +1. I think I gave you -1, +1, and then, I gave you all 3 of them, -2 and +2, and -3 and +3. So we actually went over those already. Okay, here's another one for you. So you want to find the z-score such that the area to the left is 0.9418. We went over that. And same thing here. And then you should have some to the right, I think. Yeah, there we go. We have one where the area to the right is given and you want to find that z-score. Okay, I've got a couple like that. So these should be pretty easy for you to do. Okay, let's do this one together because this is a little trickier. Assume a randomly selected subject is given a bone density test. The scores are normally distributed with a mean of 0 and a standard deviation of 1. Draw a graph and find the bone density test scores that can be used as cutoffs separating the lowest 3% and the highest 3%, indicating levels that are too high or too low. So first thing we want to do is pick the right picture. So let's take a look at our options here. So we want to figure out that's the lowest. So you want to do the lowest 3% and the highest. So sketch the region containing the lowest 3% and the highest 3%. So which of the graphs are we looking at? Are we looking at, usually let you make these bigger. Oh, here it is. Would it be this one? Oops. Lowest 3% from highest 3%. Does that look like it? Or this one be? You have to kind of scroll over here to get the graphs to go out. Okay, that's not having a top and a bottom, is it? That's only looks like it's having a top. This one looks like it has a between, and this one looks like it only has a bottom. So it looks like it's going to be what? Answer A, right? Looks like a good answer. Okay, now we want to find out what it is. So we want to find the two bone density scores that correspond to those, check those points right there. So let me find my tool so I can show you how you do this. You still have it up here? Well, maybe not. Hold on just a sec, because I thought I still had the stack on. Here it is. I still do have it. Here we go. Okay, so you're going to use the between option. Now, go to between. Now you want to find, whoops, the two z-scores that give you 3% here and 3% here. So if 3% is, let me go back to the problem. If 3% is in each of the tails, how much is left in the middle? Let me make this bigger. So if this is going to be, you're going to find the z-score that separates the lower 3% from the rest and the upper 3% from the rest. How much is left in the middle? So if I've got 3% in the bottom and 3% in the top, how much do I have left in the middle? So the whole thing is 100%. So if I take away 3, minus 3, and I minus another 3, what's left in the middle? So what's 100 minus 3 minus 3?
94.
94. Excellent. It's 94. Yes. So when you go to the tool, what you're going to do is you are going to say, I want to find the z values that define the middle 94% of the data. And it's going to find them for you. And they want, let me see what they want. 2 decimal places. So it's going to be 63.33. Let's go ahead and put them in, make sure we got it right. 63.33 and 73.87. Oops, got to get back in there. Comma 73.87. Bingo. Oh no, what did I do? I did it wrong. 2 decimal places. 73 point. What did I do wrong? 0.94, 0.94. I'm going to get to the right answer and see what we did wrong. It looks like we did it right. Let's see. It's not rounded right. Oh, they want the z-score. Oh, I'm sorry. I'm sorry. Oh, you know what I did? I didn't put in back to the standard normal. That's what I did wrong. Duh. There we go. Let's try this again. That was my fault. So it's 0.94. I left it on a different distribution. There we go. There we go. Sorry about that. I left it as some other distribution other than standard normal. That was my fault. So negative 1.88, positive 1.88. You have to reset this. See, I made that mistake. I didn't reset this to the standard normal. That was my fault. There's the z-score. Negative 1.88, positive 1.88. Okay. Sorry about that. That was my fault. See, the first thing I always tell you is go in and change the mean and standard deviation. I didn't listen to my own directions. So I got it wrong. Okay, so let's take a look at, got to get back to your problems. 6.2, because 6.2 is going to be pretty much the same thing, except you have non-standard normal distribution. So get to 6.2. And let's see what we have in here. So it's going to follow similar to the problems that I went over with you. There's going to be some definitions in the beginning. And so here's one here. So again, non-standard normal. So they tell you the mean is 100 and the standard deviation is 15. This is the IQ scores again. And you want to find what's the probability that the IQ score is 110 or less. So again, you're going to put in your mean and standard deviation. You're going to use a less than or equal to, put in the 110 and find the area of the region or the probability. So we went over one like that. We went over one like that. We've got a between one. And here's one here. Watch out. They switch it up on you here. The mean and standard deviation change here. 105 and 20, and they want to go between or less than 137. Okay, so no picture this time, but they're telling you to find less than 137. So they're telling you the direction on that one. Again, the mean and standard deviation changed. 95.2 and 15.6, and now you want to go greater than, and again, they give you hints, sketch a graph. So greater than means you're going to change it to greater than or equal to, and you're going to put in 126. And let's see, here's a between option. And there's one where they give you the area, the probability, and they want you to find the score here along the IQ score. So make sure you have the mean and standard deviation in. Same thing there. You did one like that. Did one like that. Okay. I'd like to leave some of these for you to do on your own. We did a quartile one. We did do a quartile one. And let me see, I'm trying to see. I'll do one of these. I don't want to do all these because there's some nice applications in here. Okay, we did a pregnancy one, so I'm not going to do that one. Let's do this one here. A survey found that women's heights are normally distributed with a mean of 63.8. So let me get my tool. Where's my problem? There we go. All right, so let's go ahead, make sure I do what I said you should do and I didn't do before, 63.8, and where did my problem go? Here it is. 3.6. 3.6. And I think it's going to be a standard one, but we'll see. Let's take a look. All right. And the survey found, the survey also found men's heights are normally distributed with a mean of 67.8 and a standard deviation of 3.8. Most of the live characters employed at an amusement park have height requirements of a minimum of 57 inches and a maximum of 63. Find the percent of men. See, I put the women in, so I need to go back and change that. They want me to work on the men. So the men are 67.8, 67.8, and 3.8. They want you to find the percent of men that will meet the height requirements. So we're going to do a between here. And they have to be between 57. Oh, no, that's not right. 67.8. I put in the wrong window. 67.8. Between 57 and 63. All right. You think very many men are going to be able to meet that height requirement before I hit compute? Anybody want to guess? Any guesses? The mean height for the men is 67.8 inches. Not very many. So 0.1010. And they want a percent. So you're going to multiply by 100 to get the percent. Make sure you do that. So it's going to be 10.10%. Yep. Now they're going to ask you another question. Now they want to ask you to interpret this. So since most men do or do not meet the height requirement, do not, right? Because only about 10% do. It is likely that most of the characters are men or women. What do you think? Most of the men don't meet it, so most of the characters must be women, right? Because if you look up here, let's go back and calculate for the women. What percent of the women would meet that criteria? 63.8. Let's change it and see. 63.8 and 3.6. Let's see what percent of women meet that criteria. 38.3%. Still not very high. That's pretty restrictive. But certainly far more than the number of men that would meet it. All right, so that's a nice application question. So you have a couple other application ones. I want to see if you can't work those on your own because they're kind of different applications. And we've sort of gone through. I think it's helpful for you to be able to understand reading a problem and interpreting what pieces of information you need. First thing you want to always do is put in the mean and standard deviation in the tool, like I failed to do on that one question, and then go ahead and figure out what you want to do down here. Are you doing an area to the left, to the right, or are you doing between? And are you looking for the values along the x-axis, or you're trying to find the areas? So those are kind of the questions that you have to answer as you set a problem up. All right, so let me stop sharing the screen and see what questions we have. I do want to mention for next week, a couple of announcements actually. Section 6.3, you do have some questions on your reading quiz, but there is no homework in my stat lab for that. There's really not much to ask you there, so there is no homework on that section. The other thing I want to remind you is next Tuesday is the last day to withdraw with a W. October 18th. So I always have to remind students about that. You can always see your grade in the grade book in my courses. Everybody understands that. Every week I send you out a message. I'll send one tomorrow when I update the grade book. So you always have a snapshot of what your grade is at any point. If you have any questions about where you're going or what you need to do, to do well or whatever, you can always email me, but you always can see your grade every week in the grade book. And all your work from my stat lab automatically transfers over. So you get a good snapshot of what's happening with your grade at all times. The only thing, even your reading quizzes get graded automatically, unless you don't take them, but those grades go in automatically too. So you can always see your grade in the grade book. All right, so questions as we finish up. So we're getting into the inferential statistics part of the course. So you're in the second half now, so you're halfway done. Aren't you happy about that? We are halfway through the course. So questions as we're finishing up. Anybody have questions? Now's your time. Or any questions from 5.1 or 5.2 for people that came in after we got started? Anybody have questions? We have a couple minutes left. I also wanted to mention too, everybody knows the schedule of classes for spring is now available, and you can take a look at what's available for you to take. Open special registration starts on October, let me check my dates, 24th, and general registration, I believe, starts on October 26th. So you can see the schedule of classes though for spring now. So if you're interested in registering, you might want to take a look and see what's there in terms of what you want to take. All right, questions. Everybody's so quiet tonight. Let's see. I'm going to ask you a question. It's about the reading quiz, I guess. Oh, that's Felicia. Okay, Felicia. All right, if you don't have questions, I'm done the new material, but I'm certainly willing to stay here and help you with any questions you might have for the homework for tonight or to get ready to take your test, okay? So have a good week.
Thank
We'll
you.
see you next week.
Thank you, you too.
Thank you. Have a good
Bye. Hi, Felicia.
Hi.
I'm glad you could come in.
Yeah. I want to ask you a question, but when
Yes.
everybody leaves.
Okay.
Yeah.
All right,
it's
Michelle,
about
you
the
okay?
reading.
Oh, Michelle's gone. Okay.
Yeah.
Mary, are you still with us? How about Haley? Are you still with us?
Yes.
Did you have any questions?
No, I'm okay.
Okay, you want to leave then because one of the students wants to stay to talk with me one-on-one.
Thank you so much.
Okay, bye. See you next week. Okay, Amari, did you have any questions? I don't think
Well,
she's,
I mean, the question I do have is about.
okay, I'm just going to
the-
take her. She's, okay, she's out. Okay, go ahead.
Yeah. So the question I have is about the reading that's due today, and it's about the property for the uniform distribution.
Mm-hmm.
So when I did the first quiz, I got like some wrong, so I'm gonna retake it. And maybe I can share. Can I share my screen?
Yeah, hold on just a second. Let me go back.
Oh, you're recording it too.
Yeah, let me go back for a second.
Ah.
Okay.